12 minutes?
3 minutes question.
Okay, great. All right, hi everyone. My name is Jake Roggenbuck. I'm going to be talking about whether linear time regex engines can be considered harmful. Last year I did the poster presentation. That is the poster seen on the left. And this year I was planning on doing either the poster presentation or the oral speaking section, but I will be giving the talk instead. Okay, so I want to talk a little bit about what I'm going to be covering today. And first I'm going to be talking about what regex is. I'm going to be talking about a common type of attack called RDoS attacks. I'll be talking about the solution for these, called linear time regex engines. I'll talk about my research question for specifically this spring, and then what happened and my future work. So the first is regex engines. These are called regular expressions, and these are very common in programming. When you're doing form validation or email validation, I filled out my taxes recently, I put in my email, I put in my phone number, and it was able to tell me whether my email was entered correctly or whether my phone number was entered correctly based on how it looked, right? So this is an example of a phone number validation. It checks that there are enough numbers, and this is extremely commonly used for, sanitization of data and form verification. This is very commonly used in the industry. But there is a problem with these. Some of them are written incorrectly. And if they are written incorrectly, it's very hard to tell what might go wrong. And in common cases, the time it takes for these to execute might increase exponentially. So as you can see with this graph, we have the amount of input characters, right? So imagine my email is 10 characters long. In the Go programming language, the time it takes is 0 seconds. That's the y-axis in this graph. It takes 0 seconds to execute to check that my email is correct. But as you increase it past 20 characters, the problem is with the Python regex engine, it starts increasing from 1 second to 2 seconds to 4 seconds to 8 to 16 until it won't finish executing. This is a really big problem in programming if your code won't work. And it's not just bad like, oh, you need to go grab a cup of coffee, come back, and then it will be done. This is like it will take down your servers for the entire afternoon, and money will be lost, lives will be lost. A lot of emergency services use services like Google and Cloudflare, which have had these outages before, so there's actually lives at stake when RDoSes happen. Here's the example of the Cloudflare outage from 2019. I personally remember this in summer. I was using some products that use Cloudflare. Cloudflare is one of the most common web providers for websites like Discord and DoorDash, and many of them use Cloudflare, and they actually had a RDoS attack happen by accident. When RDoSes happen, they have like CPU exhaustion. What this means is the code starts running and it won't finish in any reasonable amount of time. This is their write-up for the incident, and they could, as you can see, there is a certain matching algorithm that happened, and it just wouldn't finish in time, which caused all their services to go, or most of their services to go down for certain regions, and then subsequently everything that used those services went down. But there is a solution to this, and as you can see from the previous graph, not all languages are affected here. The Python language and their regex library was affected, but the ones written in Go and Rust were not. This is not simply because they're faster programming languages. They're actually implementing regular expression engines completely differently. They take away some of the features that would allow these attacks to happen. There's two features in particular that cause these, and Rust and Go decided to make the trade-off that they don't want to include these features just to make these libraries more safe. So that brings us to some of the linear time engines. Google made theirs called RE2, and at the bottom we can see this is actually what Cloudflare decided to do to fix their solution. They say, oh, we're moving to RE2, which is the Google library, and then also moving to the Rust regex engine. So part of the work that I did over the summer was I built my own TypeScript, JavaScript wrapper for the Rust regex library. This is the first time this has been done. This happened for Python. This was distributed through the Python package library, where someone wrapped the Rust engine for Python, put it out there so that Python could have a safe ecosystem with these regex attacks. And there was like a clear gap where nobody had done this with JavaScript and TypeScript. So over the summer I made a library called Regolith. This is the first one to use Rust's regex library, which is safe for the JavaScript and TypeScript ecosystem, which previously had no safety. I posted this on Y Combinator's news aggregator called Hacker News, and it got 5th, which I'm very happy about. That made the front page just under Anthropic's post and one of Google's blogs. So that's some of the recognition it's gotten. It is also the most popular JavaScript library to use the Rust regex engine. But it brings me to my research question. What was I actually looking into? I built this library. I wanted to check the industry and the other common libraries to see if there was any major issues. And what I defined with my professor was some specifications for what we can consider harmful. If you imagine requests coming into a server as kind of like a pipe, if you're able to handle 80 things, 80 transactions at a time, if you start accumulating more than you could handle, there's going to be latency buildup. And what this means is if your regex takes an actually a significant amount of time, like 1 second, it doesn't sound like a whole lot, but if you're not able to process your requests quicker than you're accumulating them, you actually have a buildup of these issues. So that's why I define some potentially harmful for 1 second, 10 seconds is moderately harmful, and then 100 seconds is severe. I was able to build this thing called many regex pipeline. What this pipeline is the ability to run different regex patterns with different libraries with different input lengths. So that's how I was able to generate some of these graphs previously, where I have certain regexes that I think might be exploitable. I run hundreds of different types of regexes on the dozens of libraries I checked with different input sizes to get how long they take to run. And it's kind of remarkable how exponential, like how well it fits to an exponential graph. So we have this where we run it with different libraries, with different input sizes to check which ones are vulnerable so that we can see if certain regex libraries will be vulnerable when they shouldn't be. Now there's two categories of regex libraries, and the ones that aren't safe don't feel the need to say that they're, oh, we're unsafe, it's okay. It's kind of a standard for them to be unsafe. But there are some that claim to be safe. They say we will execute in time shorter or like at linear time, no more. They promise that, and that's kind of what the research question was. Can we find vulnerabilities where libraries that attest to be safe in fact are not? So I divided them up by language. Purple is C#, the yellow is TypeScript and JavaScript, and then blue is Python. As you can see, the libraries that attest to be safe, in fact, are actually safe. That's like the Rust regex, and other ones like Regolith. You can see the RE2, like Regolith, the one I made, it has 0 timeouts. RE2 is the one by Google, it has 0 timeouts. RE# is one of the more popular ones in literature, where they published one for C#. They use the same linear time algorithms, and in fact, I couldn't verify that it had any timeouts, so I'm considering it safe for this. The one on the very bottom is Python's regex. This one is known to be dangerous, and as we can see, we have 123 times when it wasn't safe. The regex library, which is the one in blue near the middle, is another Python one. But where this gets really interesting, actually, is we find some for PyRE2. PyRE2 wraps the safe RE2 library from Google, but makes it for Python. And what we'd expect to happen is for this to be completely safe in linear time. But in fact, it actually isn't. And we found 9 times when it actually was not safe. This is something that I previously didn't know. When I audited this library that attested to be safe, I thought it was going to be safe, but this is actually a novel case where we've found something that takes longer than linear time in a library that attests to be. This is in fact because it had a fallback option that was documented, but didn't say that it would fall back to an exponential backtracking case. So I don't know of any other times where this specific library has had issues like this. So that was some novel findings for this. I sent this to a few other researchers and said, hey, I found this thing. I think it's kind of interesting. There's some potential issue with this library. It has this exponential backtracking. As you can see, there's the graph on the top of this run multiple times to see how the input characters affect the actual output time. It's still to be determined whether this is actually a huge issue, because this library doesn't as a whole claim to be linear time, but the subset of it does. This was just what I've found, and my future work will involve finding other libraries and issues like this. Yeah, that's basically the entirety of my talk. If you have any questions, please let me know, but thank you for listening.